Our world is not always the same. Hidden from our view lies a different world. Creatures utterly unlike us. Almost alien. Yet they are more numerous than any other group on the planet. Welcome to the fascinating world of the arthropods. Spiders, scorpions, and insects. Today we have new camera techniques that will allow us to reveal in greater detail than ever before their lives, the way they fight and feed and reproduce. This series uses specially developed 3D camera technology to study the micro-world in extraordinary detail, both on location and in specially constructed environments. We'll witness their births, the challenges they face, and the moments when their lives hang in the balance. And that may help us understand how it is that today over 80% of all animal species on this planet are arthropods. In this series, we'll see the way they have evolved, from the comparative simplicity of the millipede to vast colonies that contain hundreds, even millions of individuals. We'll witness the most extraordinary transformations in the animal kingdom. We'll meet ants that farm, spiders that can cast their webs, and the bug that wears the bodies of its victims as a disguise. Welcome to a strange and dangerous world. The struggle for survival amongst arthropods is often brutal, but that's a key to their success. The strongest survive to produce the next generation. The birth of offspring is not always an end to parental responsibilities. Whilst most arthropods leave their young to fend for themselves, a small minority look after them. They become families. And in the tropical forests of Australia lives one of the most surprising. This is the giant burrowing cockroach. It's one of the largest cockroaches in the world. If you were to hold it, it would fill the palm of your hand. Despite its appearance, it isn't a pest. In fact, it's one of the most useful insects in the forest. Australians call it the litter bug because it cleans up the forest floor, eating leaves and detritus. This one is a female. She's pregnant, and she's digging a tunnel in order to create a safe place where she can produce her young. Her tunnel is 1 metre deep, the equivalent of you or me digging down more than 20 metres. And here she gives birth. Having done so, most insects would leave, and their young would be left to fend for themselves. But not her. She will care for her young for months, keeping them moist and warm under her shell. Occasionally, she'll return to the surface to collect eucalyptus leaves for them to eat. This cockroach will live for 8 years or more. During that time, she will produce around 150 young. And by caring for them for the first 6 months of their lives, she ensures that every one of them gets the best possible start. Eventually, they will leave the nest and begin life on their own. But some creatures have taken social living a step further. Their youngsters never leave. The family stays together for life. This mass of white silk is home to a very unusual spider. Spiders are usually solitary, but these spiders are different. They're social. They live in groups of up to 100, and they're all related, brothers and sisters, parents, uncles and aunts, all on the same web. They live side by side and hunt together. Here too the mothers care for their young. Once these eggs are hatched, she'll feed the spiderlings by regurgitating food until they're old enough to hunt for themselves. For now, with so many spiders guarding the web, it's safe for her to leave the eggs in search of food. This mantis is far too large for any single spider to attack. So instead, they collaborate. All the nearby spiders help to hold it down. Even the smaller, young spiders lend a hand. Eventually, when their prey is exhausted, the spiders feed. It's not unusual for spiderlings to eat the bodies of older spiders that have died in the web. In fact, in some species of social spider, the mother always dies when the spiderlings hatch, and they feed on her corpse. So the generations pass and the family thrives. This vast web will persist for perhaps 5 years until eventually the family moves on. By living together as an extended family and all looking out for each other, these social spiders have helped guarantee their survival. But some insects have taken this practice a stage further. Family members have begun to specialize. In the rainforests of Australia, green ants live in groups of up to 500,000. But these communities have small beginnings. This family consists of just a few hundred ants. And they're searching for a place to build their home. The family seems to have found a suitable location. Now they can start construction. Climbing on each other's backs, the strongest ants reach across the gaps and pull the leaves together. Their nest will be made by joining these leaves. To do that, they need help from the youngest members of the family, the larvae. These tiny white youngsters are immobile, but they have a remarkable ability, which the worker ants have the skills to stimulate. When the adult workers stroke them with their antennae, the young larvae produce silk. The workers use the silk to stitch the leaves together. Some workers pull the leaves into position, and the delicate silk weaving continues. Finally, the nest is complete. It will provide a strong, waterproof, safe home for the ants. But it serves an even more important purpose as home to their leader, their queen. She is the mother of the entire family and the sole producer of young. Without her, the community will fail. Away from the rainforest, this tiny family of wasps is also ruled by a queen. But in this family, the position is not fixed, and deciding exactly who will be their leader can be savage. Arthropods, typically, produce their young in huge numbers. Some look after their offspring and stay together as families. As these families grow in size, they need organization. And many have a central figure, their mother, their queen. Across Europe and North America, there is an insect that starkly illustrates the process by which insect families choose their queen. These are paper wasps, and they live in family groups of no more than 80 individuals. The small size of the group makes them easy to observe and shows that the queen is constantly under threat from her daughters. The queen's role is to lay eggs and keep her unruly daughters in line. The daughters tend the young, their newly born sisters. They clean them and water them. They even chop up their food for them. And feed it to them piece by piece. And the queen constantly bullies her daughters to make sure they do their job. But in this small family, the role of queen is not fixed. And deciding who is queen is settled by aggression. These tests of strength have a purpose. The strongest will become the queen. To avoid unnecessary fights, the wasps have evolved the ability to recognize each other by smell. Some have even learned to recognize faces, much like humans. This enables them to constantly keep track of who has beaten whom, maintaining this uneasy truce. But the system only works because the family is so small. Just a few more wasps and the queen would no longer be able to fight them all. Bumblebees have found a way around this obstacle. Instead of dominating by brute force, their queen controls her family with chemicals. Bumblebees are able to live in larger families of about 300. The majority are workers who collect nectar and pollen to feed the rest of the family. And this is their queen. Her swollen abdomen is full of eggs. She alone lays. So she is the mother of every bee in the family. To prevent competition from her offspring, she releases a chemical, a pheromone, that renders the workers unwilling to lay eggs themselves. Unable to produce larvae, these offspring become the queen's workers, looking after the day-to-day running of their home. They clean up the debris at the bottom of the nest and build and repair the nest walls using wax. They fill and look after special food stores called honeypots. They use this honey to feed new larvae produced by their queen, their own sisters. And if any larvae aren't perfect, the workers will kill them. The queen's chemical control of her family is total. But by the standard of some insect families, this one is small. Bumblebees are found all over the Northern Hemisphere. There are about 200 different species of them. But pheromones released by the queen can only control a certain number of individuals, 100 or so at the most. To organize bigger colonies, workers need to be able to send messages to one another. It's no longer about control, it's about communication. In the rainforest of Africa, some insects live in immense families. By solving the issue of communication, their size has become almost limitless. These are driver ants. With up to 50 million individuals, this is more than just a family, it's a colony. The queen is the mother of them all. She is the only individual that's able to reproduce. And the entire community, in their millions, exists purely in order to support her. Like all of the simpler families we've seen, their success is built on hierarchy and is made possible by division of labor. Every ant has a specific role, whether it's tending to larvae, guarding the nest, or guiding a column of its sisters to a source of food. But the distance over which they can operate and the sheer size of the family is made possible by communication. Communication is the key to making a simple family a complex colony. a collection of insects that is far greater than the sum of its parts, and capable of achieving feats equal to those of far larger animals. Of all the arthropod innovations, the most revolutionary has been the ability to live in immense colonies. That has enabled them to hunt en masse, to build huge constructions for their homes, and to dominate their surroundings. Next time, I want to look at this pinnacle of arthropod achievement. Vast colonies capable of shaping the world around them. Termites that build castles that on our scale would be 2 kilometers tall. Bees that communicate by dancing. And the ants that farm fungus on a grand scale. These creatures are individually tiny, yet they live in colonies that are truly immense. And they act entirely as one. Together, they form a single superorganism.
Join David Attenborough at the same time next Saturday for the last in the series of Micro Monsters on Sky 1 HD and Sky 3D. And in another captivating day of cricket, England have taken a huge step towards going 1-0 up in the Ashes. The final day of the opening test gets underway tomorrow from 10, live on Sky Sports Ashes.